Okay guys, let's talk about rational equations, okay? So the first one asks, when solving rational equations, it is important to identify the domain of the variable. We exclude all values for the variable that result in a 0 in the denominator. So our next one is we're going to solve x plus 5 divided by x minus 7 equal to x minus 3 divided by x plus 7. Okay, so the first step is we're going to determine the domain of the variable in the rational equation. So we know that the domain, we look at the we look at the denominators and we set them both equal to 0. So if we set x minus 7 not equal to 0, we just add 7 to both sides, so x cannot equal 7, right? Same thing, let's change colors. If we set x plus 7 not equal to 0, and we subtract 7 from both sides, and we get x cannot equal 7. So for what value of x will either denominator be equal to 0? Well, that's going to be x cannot equal negative 7 or 7, right? So if we express the domain of x, I don't know, like if you guys prefer, let's just do both. If you like set notation, so x such that x cannot equal negative 7 and x cannot equal 7. Okay, there's your set notation. Now if you prefer interval notation, well then that would be, oh, I should have wrote, sorry for that. I should have said domain equals, my bad. So if you want interval notations, then that's going to be domain equals negative infinity to negative 7. Then we're going to have a union, negative 7 to positive 7. We'll have another union, and then positive 7 to infinity. Okay? So there's either answer for that. Now, the next thing it wants to know is the least common denominator of all the denominators, which that is what least common denominator is. That's kind of redundant, right? So our least common denominator would be each one multiplied by each other. So that's just going to be x minus 7 times x plus 7. Okay? So you can copy that over here if you want. Now we're going to multiply both sides of the equation by the least common denominator and simplify the expression on each side of the equation. So, totally different color here. We're going to start with our equation. Okay, so we have x plus 5 over x minus 7. And that equals x minus 3 over x plus 7. So now we're going to multiply it, like I said, by the least common denominator. So we'll multiply this side by x minus 7, x plus 7. And the same thing over here, x minus 7, x plus 7. Okay. I think that's all we're supposed to do there. Yeah, we multiplied. Now on the next step, which I'm going to go ahead and do up here. I don't want to rewrite it again. We've talked about this many times. Shelley's a little lazy. So what we're going to do is we're going to divide out the like factors. So our x minus 7 will cancel, okay? And our x plus 7 will cancel. So now down here I'm going to like just write out what has been divided out, if that's okay with you guys. So we're going to have x plus 7 times x plus 5. That's going to equal x minus 3 times x minus 7. Okay. Now we can multiply, which means FOIL. Wow, what color I haven't used. So we'll FOIL these out. This is going to give me x squared. When you go ahead and do it all the way together, that's going to be 5x plus 7x will be 12x plus 35. That's going to equal x squared minus 3 minus 7 is going to be negative 10x plus 21. Now we can solve for x. We can just combine like terms. And this is what's cool. If you have the same term on both sides of a equal sign, it just automatically cancels, right? Because you would subtract it on both sides, so we know that this is going to cancel, right? So if we add 10 to both sides, 10x, it's going to give us 22x, right? And then if we subtract 35 from both sides, okay, so this will cancel and this will cancel. So that's going to give us 22x equals negative 14. And then we can divide by 22. So that's going to give us, I'm going to write it down here, x equals negative 14 over 22, but we could take that simpler, right? We always simplify as far as we can in college algebra. So it's going to be 7 over, guess it, 11. So our solution set will be negative 7 over 11. Okay, so now let's solve number 3. The first thing we want to do is determine the domain of the variable. So we look and we have x in the denominator, so we know that we have to set that equal to 0, so, or not equal to 0, sorry. So we would solve for that, so divide by 3, so x cannot equal 0, right? And it would be the same thing for x squared, so our x cannot equal 0. We can write that two different ways. Shouldn't do that. We should say, let's do set x such that x cannot equal 0. There we go. And you can turn that into interval if you wish. Now, determine the LCD of the denominators. Well, we know that 2 and 3 go into 12, right? So that would be the least common denominator. And x, well, goes into x squared, so out of the variable, that would be the least common denominator, so our LCD is going to be 12x squared. Okay. Now we're going to multiply both sides, or I like to say each term, by the LCD, and then we're going to find our equation. So we have, I don't have a lot of room for this one, so we have x over 12 plus 1/2, and that equals 1 over 3x plus 2 over x squared. Okay, so now we're going to take each of these and we're going to multiply them by 12x squared. So 12 cancels out that 12, right? And 2 goes into 12. I'm going to put this 6 right here. 3x goes into 12x squared 4x times. And x squared cancel. So we can bring this down here, and that x squared times x is going to give us x cubed, well, plus 6x squared. And that's going to equal 4x plus 24. But I'm going to write that over here so we have more room. How about that? Because we still have to do some more work. Okay. So now we want to get this in descending order, so we will move our 4x and our 24 over. So that's going to be x cubed plus 6x squared minus 4x minus 24 equals 0. And there's our equation for C. Okay? And then now we just solve. So we have 4 terms, so that just tells us that we're going to have to do by grouping. Remember, the negative goes with, so we're going to put a little plus sign here. So we know that it's not factors already. Our greatest common factor from the first grouping is going to be x squared. So it's going to be x plus 6. Greatest common factor from our second grouping is negative 4, so that's going to be x plus 6 again. All this equals 0. So I'm going to go up here. Okay. We know what's on the outside is automatically a factor. And since these are the same, they're a factor. And then we solve, right? So set each one equal to 0. So this is going to be x equals negative 6, and this is going to be x equals plus minus 2. So our answer for 3D is going to be negative 6, negative 2, and 2. And then this x cubed plus 6x squared minus 4x minus 24. Okay? All right. So now we're going to solve number 4. So determine the domain of the variable when we see that it can't be negative 1 or 1, right? So x such that x cannot equal negative 1 and x cannot equal 1. So our LCD, what would it be? The LCD would be these two multiplied together. And we know that because x squared minus 1 is the difference of squares, so that is x plus 1 times x minus 1. So these are the factors of the difference of squares. Now we multiply both sides of the equation by the LCD and solve the resulting equation. And then what is the solution of the equation? So when we do this, we're going to have 6 over x squared minus 1 equals, I gotta scoot this over, so 5 over x minus 1 minus 3 over x plus 1. So we're going to multiply this side by x minus 1, x plus 1. This side by x minus 1, x plus 1. That's close. And then this side by x minus 1, x plus 1. Okay? Now since this guy factored is these factors, we can just cancel that out. Okay? And then the x minus 1 cancels, and the x plus 1 cancels. So all we have left on the left-hand side is 6 equals 5 times x plus 1 minus 3 times x minus 1. Now we can distribute. So we're going to get 6 equals 5x plus 5 minus 3x plus 3. When we do all this math, we're going to get 6 equals 2x plus 8. If we can subtract 6, we're going to get 2x plus 2 equals 0. Go over here. So this is going to give us 2x equals negative 2. We divide by 2, so x equals negative 1. But we know that x cannot equal -1, right? So our solution set is going to be the empty set. Okay? Because our one solution, our one proposed solution, is not a good answer. So there's no answer. So it's the empty set. Okay. So now let's do number 5. So we're going to solve this equation, but to do so we have to factor x squared minus 6x plus 8. So we know there's two x's, and it's the factors of 8 that add, sorry guys, I'm getting cold, that add to be -6. So factors of 8 that add to be -6 is going to be -4 and -2, right? So this is going to be x minus 4, x minus 2. And we see that that is the factors that we have here. So that's going to be our LCD. I skipped one, didn't I? Let's talk about the domain. So what can x not equal in this equation? Well, if you said 4 and 2, you're correct, right? So our domain is going to equal x such that x cannot equal 4. Oh, let's do it in order, shall we? 2 and x cannot equal 4. I think this should just be a comma. I don't want to keep it semicolons. So again, we're going to multiply each term in this, both sides, whatever, however you want to say it, by the least common denominator, and then solve. Okay? Oops. Sorry, guys. My hand's going crazy. Okay. So we're going to have 5 over x minus 4 plus 3 over x minus 2 equals x squared minus x minus 2. And you could write this as this polynomial, or you could write it factored. I'm going to go ahead and write it factored so it's easier to see. And then this is going to be times okay. Now we cancel. So our x minus 4's cancel, our x minus 2's cancel, and this whole thing cancels. Okay, so that's just going to leave us 5 times x minus 2 plus 3 times x minus 4 equals x squared minus x minus 2. May run out of room on this one. Eek. So 5x minus 10 plus 3x minus 12 equals x squared minus x minus 2. So that's going to give us 8x minus 22 equals x squared minus x minus 2. And when we move this 8x and this 22 over, I'm going to go this way over here. So we're going to have x squared minus 9x plus 20. Okay, because I subtracted minus 8x plus 22. Oh shoot, 22. And all that equals 0, because that would have been subtracted over here too. And then we just solve, right? So that's 2 x's. Factors of 20 that equal 9. So that's going to be x minus 4, x minus 5 equals 0. So we know that x is going to equal 4 and x is going to equal 5. Well, we see that x cannot equal 4, so this one is bad. So our solution is going to be 5. Okay, so you always have to check your solution, your proposed solution, against your exclusions. Okay. So solve equations including rational functions. So we have the function f of x equals x plus 7x. So when f of x equals 8, what points are on the graph? So we just set it equal to 8 and then we solve for it, okay? So we're going to write our equation. We're going to have x plus 7 over x equals 8. Okay. And then what is our domain? Well, we know we can never have a 0 in the denominator. So this was a, by the way. So our domain is x cannot be 0, right? So domain equals x such that x cannot equal 0. Okay. Determine the LCD of the two denominators. Okay, so the least common denominator of the two is going to be, well, this is written over 1, right? So the least common denominator is going to be x. Now we're going to multiply both sides of the equation by the LCD and solve the resulting equation. Alright, so we're going to just multiply everything by x. Okay, so if we multiply this by x, this by x, and this by x, let's see what we get. So that's going to give us x squared. Well, these x's are going to cancel, so that's going to leave us with 7, and this is going to give us 8x. Okay, so now we need to multiply, or subtract 8x from both sides. Golly, that was easy for me to say. So x squared minus 8x plus 7 equals 0. Now we just have to solve, right? This is a polynomial that we can easily solve. We have two x's, and it's going to be minus 7 minus 1 equals 0. Okay? Now, this is going to give us x equals 7 and x equals 1. So our solution set is going to be 1 and 7. And now the ordered pair. What are the ordered pair going to be? Pairs, I guess, would be the correct word. But we know that 8 was our y, right? So we're going to have 1, 8, and 7, 8. Alright. Man, this was a long video. I apologize for that. Okay, so my portion's finally done, and now it's time for you to do yours. So I'm going to leave it with you. If you have any questions, as always, get a hold of me, and have the very best day.